become a Twitch partner for AP. AP Cal.
Shoot, does that link work? Oh yeah, it does. Hold on, wait. I'm just gonna wait a little. Wait, hold on. Copy. Does it work, Zach?
Let me see this.
I haven't started yet.
Yeah, I see the Google Slides.
All right. Can you see like my whiteboard too?
I can now.
You can't?
I can.
All right. I'll just wait a little.
Yo.
Hello.
Hi.
That was me.
I'm just gonna wait for Nate, some other people.
Where's this slide from? Did you make this?
Yeah, I like made it just like put.
Aaron, can you send the Twitch
Yeah.
link or wherever you're streaming in Discord?
Yeah. Oh yeah, I'm gonna stream it here too. I just did the Twitch for.
Okay.
But yeah, I'll send it though.
Oh.
The Twitch stream. Dude.
Yeah.
Who that?
Derek.
Hello?
Hello?
Yo. Bruh, Brad? Oh, Derek.
What?
It's Derek.
I got like
Down.
a fat headache.
From what?
I don't know.
Wait, hold
How
on.
much are we reviewing?
Like everything.
Okay, good.
I'll do practice problems too.
How many slides are there?
Like 26.
These.
Okay.
Hi.
Okay. I'll just start it. Unless we're expecting. Yeah, no. I
So
think
do you have
that's
it?
all.
Do you have it so your Twitch stream save? No.
Yeah, it saves. So, because some people
you have
wanted to
videos?
watch it, but they wanted to go to Math Help too, so I just recorded it. All right, we're just
Yeah,
gonna
just
start.
make sure you have video.
Okay, so limits.
Not delay. Screw that.
So normally, you look at it like this. At point A, what's f of a? It's that. When in reality, the function could look something like that. So what limits are, is they look at it like this. What value does it approach? So even though the value could be right there, it approaches the other value. Okay. So, okay. So for continuity, okay, sorry. So for continuity, it's continuous when the limit equals the value. So for this one, this is an example of like one-sided limits. So if you look at 1, when it approaches from the left, it's 4, and when it approaches from the right, it's -2. Both of those limits exist, but the limit as it approaches 1 does not exist because the left-hand limit does not equal the right-hand limit. Okay. So example, so for this one on the right, so whenever you want to find like limits as x approaches infinity, if the coefficients are the same, you do the highest powers are the same, you just do the coefficients. So in this case, it'd be -2 fifths. But if the numerator power is greater, it'll be infinity, and if the denominator power is greater, it'll be 0. So this is an example problem. The graphs of functions f and g are shown in the figures above. Which of the following statements is false? Okay, so the limit as x approaches 1 of f of x is 0. That is correct. It approaches 0 as x approaches 1. the limit as x approaches 2 of g of x does not exist. That is true because from the left it approaches 1, from the right it approaches -1. The limit of f(x) as x approaches 1 of f of x times g of x plus 1 does not exist. Okay. Here, this is, oh, whoops. This is what you have to do. So the limit as x approaches 1 of f of x times g of x plus 1. That is the limit. That's basically f of 1 times g of 2. But, so let's do it from the left. From the left, f of 1 is 0 and g of 2 from the left is 1. So, whoops. One sec. Okay, so that's 0 times 1 from the left. From the right, it's f of 1 times g of 2, but from the right, it's 0 times -1, since from the right, g approaches -1. So the left-hand limit is 0, and the right-hand limit is 0. So that limit is 0, so it does exist. So this statement is false. And now D is true. F of 2 times G of 1, those are both, G of 1 is 1, F of 2 is -1. That limit exists. Okay. Intermediate value theorem. So if F is continuous on a closed interval and M is any number between F of A and F of B, there is a number C such that F of C equals M. So if you visualize it like this, it's like there has to be a number, like a value between F of A and F of B pretty much. Okay. Okay, L'Hopital's rule. So basically, if you have a function and you like plug in the value, the x value, and you get an indeterminate form, you can just take the derivative of the numerator and the denominator until you can like get an answer. And examples of indeterminate forms are 0 over 0, infinity over infinity, that kind of stuff. Okay, so this is an example problem. One sec. Okay, so let f be the function given by f of x equals x squared minus 2x minus 1 times e of x. So you can rewrite this as f of x equals x squared minus 2x minus 1 over e to the negative x. So as you take the limit as, let's just do this one first. As x approaches infinity, you get infinity at the top and then 0 at the, oh wait, yeah, 0 at the bottom. So that's an indeterminate form, I'm pretty sure. So you can do 2x minus 2 over negative e to the negative x. And then if you plug in infinity, you get infinity over 0 again. So you can do 2 over e to the negative x. So 2 over e to the negative x is 2 over, if you plug in infinity, it's 2 over 0. And when the denominator is infinitely small, it's 2 over 0, it approaches infinity. So that's positive infinity. Negative infinity, it's the same thing. So if you plug in negative infinity in the numerator, you get negative infinity. If you plug it in the denominator, you get infinity. So that's an indeterminate form. So you can do L'Hopital's rule. Numerator, you get negative infinity. Denominator, you get infinity. So do it again. And then numerator you get 2, denominator you get infinity, so it's 0. Because if the denominator gets infinitely big, then the number is 0. The limit is 0. So that's that. Okay. So actually, we'll stop here. We'll do some more limit practice problems real quick. One sec. Okay. Hold on, let me fix my stream. Okay. So, first problem is this one. The graph of function f is shown above. Which of the following statements is false? Okay, so the limit as x approaches 2 of f of x exists. That is true. From the right, it approaches 2. From the left, it approaches, or from the left, it approaches 2. From the right, it approaches 2. The limit as x approaches 3 of f of x exists. That is true. From the left, it approaches 5. From the right, it approaches 5. The limit as x approaches 4 of f of x exists. That is not true because from the left, it approaches like 1.9 blah blah. From the right, it approaches 4. And the limit as x approaches 5 of f of x, that exists. That's true. Because it approaches 6. And it is continuous at x equals 3 because the limit equals the point. So C is the answer. C is false. For which of the following does the limit as x approaches infinity of f of x equals 0? Okay, so you could just do L'Hopital's rule for all of these. So for 1, if you plug in infinity, you get infinity over infinity. So you can do 1 over x to 99, which can be rewritten, or not x to 99, 99x to the 98. You can rewrite that as 1 over 99x to 99. And as you approach infinity, it becomes 1 over infinity, which is 0. So 1 works. So let's try this one. If you plug in infinity, you get infinity over infinity. So that can be e to the x over 1 over x, or e to the x times x. So, but in order to do L'Hopital's rule again, or you get infinity times infinity, but in order to do L'Hopital's rule again, you have to write it as a fraction. So that can be rewritten as x over e to the negative x. So that's infinity over 0. So we can do it again. You do 1 over negative e to negative x, and that is 1 over 0, which is infinity. So that does not work.
Wait, I have a question.
Yeah.
How do you know, like, if e to the, or, like,
I think I know what you mean.
Okay.
Like, how do I know that at e to negative x, as you approach infinity, it approaches 0? Like something like that? Okay, well, basically, it's just like how exponential functions work. So, like, they're like this.
Oh, yeah, it looks like that.
So if you approach negative infinity, it like always asymptotes at 0. So that's basically how I knew. So, yeah, that's basically how you know.
No, yeah, that makes sense. Thanks.
Okay, so for this one, you get infinity over infinity again. So you can do L'Hopital's rule, but here's the thing. You're gonna keep getting infinity over infinity because it's gonna keep being like a exponent function over an exponential function. So, but if you notice that if you keep going, you're gonna slowly get to like a constant if you keep deriving the, like, using power rule. So you're gonna keep getting a constant, and then e to the x, the derivative of e to the x is just e to the x. So you're going to get a constant over e to the x. And then as you approach infinity, the denominator approaches infinity, so it's 0. So 1 and 3 are both work. Like, does that make sense? Like, how you can get a constant?
Yep.
Okay.
Will the constant be 99 factorial? Is it not?
Yeah, wait, yeah, it actually would. Okay, so the graph of a function f is shown in the figure above. Which of the following statements is true? F of a equals 2. That is not true. F of a is equal to 1. F is continuous at x equals a. That is not true because the limit does not equal the value. The limit as x approaches a of f of x is 1. That is not true. It approaches 2, not 1. The limit as x approaches a of f of x is 2. That is true. And the limit of f as x approaches a of f of x does not exist. It does exist because from the left you approach 2, from the right you approach 2. Okay. The figure above shows the graph of the function f. Which of the following statements is true? The limit as x approaches 2 from the left of f of x is equal to f of 2. So from the left, it approaches negative 1. And f of 2 is negative 1. So that's true. The limit as x approaches 6 from the left of f of x is equal to the limit as x approaches 6 from the right of f of x. From the left, it approaches negative 1. From the right, it approaches negative 1. That's true. The limit as x approaches 6 of f of x is equal to f of 6. That is not true because f of 6 is negative 3 and the limit is negative 1. So that's not true. So it's 1 and 2 only. The limit as x approaches infinity of x cubed times e to the 3x is, so if you plug in infinity, you'll get infinity over infinity. So you can do L'Hopital's rule. So that's equal to 3x squared over 3e to the 3x. So infinity over infinity again, so 6x over 9e to the 3x. That's infinity over infinity again. So you can do 6, 27e to the 3x. Yeah. So that is 6 over infinity, which is 0, pretty sure. One sec. Okay. Wait, Zach, what are those things you sent me?
Oh, nothing.
Okay. Okay, this one. Let f be the function defined above. For what value of b is f continuous at x equals 2? Okay, so first let's find the limit as x approaches 2 from the left and the right. So from the left, you can find the limit by factoring. So x minus 5 over b. And as x approaches 2, it will be negative 3 over b. And from the right, as x approaches 2, it's b, because it's like a constant. So in order for f to be continuous, we want b to be equal to negative 3 over b. So we want b squared equal to negative 3. But b squared can never be equal to negative 3, so e is the answer. Okay. And the limit as x approaches 3 from the left of the absolute value of x minus 3 over x minus 3 is. Okay. So when you approach 3 from the left, of the absolute value of x minus 3, you can rewrite this as 3 minus x over x minus 3. Because the absolute value of x minus 3, it's just when x is less than 3, it is 3 minus x. But when x is greater than 3, it's x minus 3. Because that makes sense, because you want x minus 3 to always be positive. But if x is less than 3, so for example 2 minus 3, that would be negative. So it's basically 3 minus x when x is less than 3. So you can factor out a -1, and then you get -1. So B is your answer. Does that, like, any questions on that? That's can be kind of confusing, but yeah. We just did that one, and then this one. So let f be the function given by f of x equals that. If the line y equals b is a horizontal asymptote to the graph, then b equals. Okay. So the horizontal asymptote is the limit as x approaches infinity of that function. So if you remember in that other slide, for limits with infinity, if the highest power of the numerator and denominator are the same, then you just do the coefficients. So I see that they're both going to be the same because they're both going to be x squared. So I see 2x squared, blah, 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 over x squared, blah, blah, blah. So that would just be 2. I mean, or you could actually just fully factor it out. But if you see that the highest powers, if you notice that right away, you don't really need to do that. So C is the answer.
Wait, how'd you know to do limit as x approaches infinity?
Because that's the definition of what a horizontal asymptote is. The limit as x approaches infinity. Okay, so that's it for the limits practice problems. Were there any questions before I move on?
Can you post these somewhere?
Sure, yeah.
On the Discord or Classroom?
Sure. Okay, then I'll move on. One sec. Okay. So derivatives, they're the slope of a tangent line or the instantaneous rate of change of a function. The limit definition of it is this. Limit as h approaches 0 of f of x plus h minus f of x over h. This is an example of a problem where you would need, your understanding of this would be really helpful. So if you can see that this is in the derivative form, you can see that, hold up one sec. You can see that f of x would be equal to e to the negative x. Because, hold on, of e to the 1 minus h minus. And then the derivative form is f of x plus h minus f of x over h. So x is 1 and f of x is e to the negative x. So f prime of, so basically this limit is equal to f prime of x. So f prime of e to the negative x is negative e to the negative x. And then if you plug in 1, it's negative e to the negative 1, which is negative 1 over e. So B would be that answer. Okay, here are some rules you should know. Power rule, quotient rule, product rule, chain rule. You should know these. For these, I mean, I guess if you already know them, it's good to review them. If you don't know these, I mean, it's not like that bad if you don't know them. But yeah, you should know sine x, cosine x, all this stuff, and then know all these rules. I'm just gonna move on. Okay, linear approximation. So basically, what linear approximation is if you know that the tangent line from at one point, you can use that tangent line to approximate the value of a point close to it. So for example, we know at x equals a, we know the tangent line right here. But say we want to know, oh, but what's f of b, which is like say b is like really close to a. We could just use the tangent line to approximate. And in this case, even though f of b would be this red dot, we'd approximate f of b as this blue dot. So it's an underestimate. And that's also something good to know. When it's concave up, the tangent line is an underestimate. And when it's concave down, the tangent line is an overestimate. So f of x, this is the equation for a linear approximation. Okay, and we can use that to sorry. Implicit differentiation. Okay. So, oh wait, let me do this problem real quick. Sorry, I got distracted. Here. Okay. So for t is between 0 and 24 hours, the temperature inside a fridge in a kitchen is given by the function w that satisfies the differential equation dw over dt equals 3 cosine t over 2w. W at t equals 0, the temperature is 3. Okay, so we know that w of 0 equals 3. So write the equation for the line tangent to the graph at point t equals 0. So we want to know the slope of the tangent line, but we are given dw over dt. So we'll plug in cosine 0 over 2, 3 equals 3 over 6 equals 1/2. So y minus 3 equals y minus 3 equals 1/2 x minus 0. So y equals 1/2 x plus 3. Okay, so use that equation to approximate the temperature at t equals 0.4. So all you have to do is plug in 0.4 into the equation for the tangent line. You don't need to use that equation for this one because we already know the tangent line. So that's 1/2 times 2/5 plus 3, which is 1/5 plus 3, which is 3.2. Okay. So that's that. Okay, implicit differentiation. So you differentiate both sides of the equation, and then whenever you derive a y, you also have to include a dy dx, and then just isolate the dy dx and solve for it. So in this example, you derive this right here, you do for 2x squared, you can just do power rule 4x. But for this one, you have to do power rule but then also include a dy dx. And then just isolate the dy dx, and you get that. Okay. Related rates. So if you approach, the way to approach related rates is, if it helps, it usually helps to draw a picture of like the situation and then write an equation that relates the variables that you're given, and then take the derivative of both sides. But you have to remember to do implicit differentiation, and then solve for your quantity. So I'll do these two practice problems. One sec. Hold on. Okay, here. Okay. So where was that? 24, right here. Okay, sand is deposited into a pile with a circular base. The volume V of the pile is given by V equals R cubed over 3, where R is the radius of the base. The circumference of the base is increasing at a constant rate of 5 pi feet per hour. When the circumference is 8 pi feet, what is the rate of change of the volume? Okay. So sand is being deposited into a pile, and the volume of that pile is R cubed over 3. And the circumference of the base, we know that circumference is 2 pi r. So we want to find rate of change of volume. So we want to find dv dt. So circumference of the base. Okay, so we want to relate circumference to volume. So to do that, we could substitute in for r. So we could say that r equals c over 2 pi. So v equals c over 2 pi cubed over 3, which is c cubed over 6, or no, not 6, over 8 pi cubed times 3. So if you take the derivative of both sides, you get dv dt equals c squared over 8 pi cubed dc dt. So you can plug in, we know circumference is, what is it, 8 pi. So that's 64 pi squared over 8 pi cubed. And we know that it's increasing at 5 pi feet per hour. So there's a lot of pi's here. Okay. So that's 8 pi squared over pi cubed times 5 pi. And then the pi's cancel out. So it's just 40. So C should be your answer. Okay. And then the latter one, this one. Hold on, I need to do something real quick. Okay. So for this ladder problem, there's a 15-foot ladder. It's sliding down at 2 feet per second. What is the rate of change of the angle? Okay, at the moment that it's 9 feet from the base. So we need to draw a diagram. So let's call this x, y, theta, and then this is constant, it's 15. So we want to find dy no, d theta dt. So if we say that, say sine theta equals y over 15, that means that cosine theta d theta dt equals 1/15 dy dt. What's cosine theta? Cosine theta is adjacent over hypotenuse. But what's adjacent? We know that it's 9 feet from the base of the wall. So it's 9 over 15 d theta dt equals 1/15. What's dy dt? It's -2 because it's sliding down at 2 feet per second. So d theta dt equals -2/9. A. Okay, that's it for those related rates practice problems. So I'll go back. Oh, wait, on Twitch. Okay. Okay. Interpreting graphs. So f prime of x is the derivative. Whenever it's greater than 0, that means the function is increasing. And whenever it's less than 0, that means the function is decreasing. Whenever it changes from negative to positive, that's a local minimum. Whenever it changes from positive to negative, that's a local maximum. Whenever the second derivative is greater than 0, it's concave up. Whenever the second derivative is less than 0, it's concave down. And this is an example of what concave up looks like. You see the slope is always increasing. Concave down, you see the slope is decreasing. Concave up usually looks like a smiley face, and concave down usually looks like a frown, but it doesn't always have to look like that. But if you see that, that's a good teller. Okay, so let's do this practice problem. So the figure above shows f prime. If f is 0 equals 0, which of the following could be the graph of f? Okay, so f of 0 has to be equal 0. But that's the case for all of these, so we can't eliminate any. So let's look for critical points. So when f prime is 0, that's a critical point. So 2 is a critical point and 3 is a critical point. And 2, it goes from positive to negative, so that's a local max. And at 3, it goes from negative to positive, so that's a local min. So let's look for a local max at 2 and a local min at 3. So it's not A, it's not B, it could be C, it could be D, and it's not E. So between C and D. All right, let's see what else we could see. You see there's technically a critical point at 0 and 4, or the derivative should be 0 at 0 and 4. So that means that the function of f at 0 and 4 should be approaching like a peak or like a trough. So you can see that at 4, it's starting to like peak, and at 0, it's starting to like be like a minimum. But for this function, it's just increasing, and then it's just straight up increasing. So that's how we know that C is the right graph. Yeah.
I think for C, for that one, you could also see that from 0 to 2, it stays increasing, but the time it spends under the x-axis is really small. So for D, it probably wouldn't be able to go all the way from the peak of 2 to down to where -3 is.
Yeah, that's true. That's true. That works too. Okay. So mean value theorem. So if f is continuous on the closed interval a to b and differentiable on the open interval a to b, there is a number c such that the derivative at c is equal to the average rate of change. So from A to B, there's a value C with the slope parallel to the equal to the average, the secant line. The tangent line is parallel to the secant line, basically. Okay, so optimization. So I actually, like in all the practice tests I looked for, I couldn't find any optimization practice problems. So that's, I guess, a good sign. But if there were to be an optimization problem, you would want to identify the equation, or so, well, this is an example. We want to create a box with an open top and square base with a surface area of 300 square inches. What length of the base will produce a box with the maximum possible value? So you want to maximize volume, and volume is equal to x squared times the height. Identify the constraint equation. So the surface area has to be 300, and the surface area is x squared plus 4xh equals 300. So you want to eliminate a variable. So let's sub in, well, we don't care about height, we only want to know the length of the base. So let's make h equal to 300 minus x squared over 4x, and then plug that into the volume equation. So now we have v and x. So in order to maximize it, we have to set the derivative to 0 and solve for critical numbers. So the derivative is 75 minus 3/4 x squared. If you set that to 0, you get x equals 10. Yeah. All right, so that's it for the derivative. So let me do some practice problems. One sec. Okay. Wait, Nate, you could just say that real quick.
Okay. So I know I don't know if I've like if they're on the actual AP test, but there's sometimes problems where they'll give you the first derivative, they'll tell you it's 0, so you know it's a critical point, but then you might have to like identify whether it's a maximum or a minimum depending on the second derivative. So just the way for that is if the second derivative is negative at the critical point, you know it's going to be a maximum because when the second derivative is negative, it's concave down. And then the critical point for a concave down area would be the peak of it where it switches direction. And then when the second derivative is positive, it's going to be a minimum because that's at the, I guess, at the lowest of the curve for the concave part, I guess.
Yeah. So basically, yeah, what he said. Okay, so I'm going to do some practice problems. So what is the equation of the line tangent to the graph of x squared minus 3xy equals 10 at 1, -3? So this is implicit differentiation. So 2x minus 3, and then xy, we have to do product rule. So that is, the derivative of x is 1, so 1 times y, plus the derivative of y is dy dx times x equals 10. So 2x minus 3y plus x dy dx equals 10. So dy...
Would it not be 0?
Oh, yeah, sorry. Good catch.
Thanks.
Okay, yeah, 0. And then, so dy dx is equal to 3y minus 2x. Whoops. 3y minus 2x over x. So you plug in -1 or 1 and -3. It's -9 minus 2 over 1. It's -11. So A is the answer. Okay. So the next one, let f be a differentiable function such that f of 0 is -5 and f prime of x is less than or equal to 3 for all x. Which of the following is not a possible value of f of 2? Okay, so the maximum rate of change is 3. So that means that if f of 0 is -5, let's just say f prime of x is equal to 3. That's the maximum. That means that f of 1 would be -2 and f of 2 would be 1. So 1 is the maximum possible value for f of 2. So 2 is not possible. Okay.
Wait. Can you re-explain that?
Yeah. So f prime of x is less than or equal to 3. So let's just find.
Oh wait, I thought that said f double prime of x.
Oh.
Okay, never mind.
So do you get it?
Yeah.
Okay. Let f be the function given above. What are all values of a and b for which f is differentiable at x equals 1? Okay, so first let's find when f is continuous at x equals 1. Because in order for it to be differentiable, it has to be continuous first. So we just plug in 1 for x. So b plus 1 equals a. So that has to be true. So now let's find when it's differentiable. So the derivative from the left has to equal the derivative from the right. So the derivative on the left is 1, and the derivative on the right is 2ax. And when x is equal to 1, so that's 2a equals 1. So a has to equal 1/2. So and a has to be equal to b plus 1. So b is equal to a minus 1. So that means b is -1/2. So a is the answer. So first you have to find when it's continuous by solving for the limit as x approaches 1 from the left and the right, and then solve for when it's differentiable by doing the derivative from the left and the right and setting them equal to each other. All right. So this one, you can notice that it's the limit definition of a derivative, and it looks like arcsine is the function. So arcsine is the function. So we know that this limit is equal to 2. So f prime of a is equal to 2 because a is like the value. So this is actually a good time. This is where it's good to know the derivative rules for like the inverse trigonometric functions. So the derivative of arcsine is 1 over square root of 1 minus x squared. And we want that to be equal to 2. So 1 equals 2, 1 minus x squared. 1 minus x squared equals 1/2. 1/4 equals 1 minus x squared. X squared equals to 3/4, and x is equal to square root of 3 over 2. So B is the answer. Okay. Next. If ln 2x plus y is equal to x plus 1, then dy dx is equal to... Okay, so this is implicit differentiation again. So... one sec. Okay, so 1 over 2x plus y times 2 plus dy dx because that's chain rule. So the derivative of ln is 1 over x, so it's 1 over that whole thing, but then you have to do the derivative of the inside, so that's why I did that. Equals to 1. So 2 plus dy dx over 2x plus y equals to 1. So 2 plus dy dx equals 2x plus y. Dy dx equals 2x plus y minus 2. B. Okay. So let f be the function defined by f of x is equal to 2x plus e to the x. If g of x is equal to, so g of x is the inverse of f of x, and the point 0, 1 is on f. So if f is 0, 1, that means that on g there's a point that's 1, 0, since it's the inverse. So g prime of 1. So g prime of 1 is equal to 1 over f prime of g of 1. And that's just like the inverse derivative rule. So g of 1 is 0. So it's equal to 1 over f prime of 0. So what's f prime of 0? F of x is equal to 2x plus e to the x. So f prime of x is equal to 2 plus e to the x. F prime of 0 is 2 plus e to the 0, which is 1, equals 3. So B is the answer. This is a related rates problem. The volume of a sphere is decreasing at a constant rate of 3 cubic centimeters per second. At the instant when the radius of the sphere is decreasing at a rate of 0.25 centimeters per second, what is the radius of the sphere? Okay, so we wanna, the two like variables that we wanna relate each other to is volume and radius. So we already know the relationship between them. V equals 4/3 pi r cubed. So you just derive both sides. Equals 4 pi r squared dr dt. dv dt is -3. We don't know the radius of the sphere, but we know that dr dt is -0.25. Or let me write that as -1/4. So -3 is equal to -pi r squared. So r squared is equal to 3 over pi. So r is equal to square root of 3 over pi. And this is a calculator problem. So let me just plug that in real quick. 0.977 E. Okay, so we already went over this problem, and this one, and this one. So let's do this one. H of x is f of x times g of x. What is h prime of 6? So you have to use product rule. F prime of x g of x plus g prime of x f of x. So, and we want to know h prime of 6. So what's f prime of 6? Well, 6 is 1, 2, 3. 6 is right here. So f prime of 6, this is a straight line. So we just want to find the slope of this line. Well, I can see that it goes down to over 1. So that's a slope of -2. And then what's g of 6? G of 6 is right here. and that is 4. And then what's g prime of 6? So it's a straight line again. So we want to find the slope of this straight line. I can see that it goes down 1 and over 2. So that is negative 1/2. And then f of 6 is right here. That's 2. So negative 8 minus 1 equals negative 9. A is the answer. Hold on. Okay, yeah, I think I did this wrong. Y plus x d. Okay, yeah.
3x dy dx.
Yeah. So, yeah, I forgot a 3 here and a negative sign. So 3y minus 2x over negative 3x. So that should be a negative, oh, whoops. And then, so if you plug in the values, it's negative 9 plus 2 over 3, negative 11 over 3. Oh, wait. No, it's not negative 9, sorry. It's 9 plus 2. Wait, hold on, sorry.
It should be 11 over 3.
Yeah, it's 11 over 3. So, yeah, E is the answer, not A. Okay. So, yeah, this one was A. Okay, so the velocity of a certain type of wave is given by v of h equals 3 squared root of h, where h is the depth. So what is the rate of change of the velocity with respect to the depth when the depth is 2 meters? So we can just, this is just a derivative function. So v of h equals 3 squared root of h. So what's the derivative? What's v prime of h? It's 3 over 2 square root of h. So when h is 2, it's 3 over 2 square root of 2, which is c. Let me just double check. Yeah. We did this. Okay, last one. So positive variables p and c change with respect to time, and the relationship between p and c is this. At the instant when dp over dt is equal to 41 and c is equal to 15, what is the value of dc dt? So just derive both sides. So 2p dp dt equals to 3 20 minus c squared times negative dc dt. That's chain rule, what I just did. So at the instant when c is equal to 15. Okay, so we want to find what's p when c is equal to 15. So p squared is equal to 125. So p is square root of 125, which is equal to 5 square root of 5, I think. So 10 square root of 5 times 41 equals to 315 squared times negative dc dt. So 410 square root of 5 over 3 times 225 equals dc dt. Gosh. Wait, hold on. Wait, Nate, am I doing something wrong here? Or
No, I think you're good. The answer should be D, I think.
okay. So 225 times 3. So negative 410 square root of 5 over 675. Are you sure? Wait, is this the same? I think I did something wrong. Oh wait, it's 5, not, or C is 5 or 15, not 5. 5 right here. So
Yeah, 410 over 75.
yeah. 75. And if you simplify that, you get negative 82 square root of 5 over 15. So D. Okay, that's it for the derivative practice problems. So, hold on. Okay. So integrals. So derivatives are the rate of change in the slope of a tangent line, but integrals are the accumulation of change, like how much change has occurred, and they're the area under the curve. So if you want to approximate the area under the curve, you can use Riemann sums. And there are left-hand sums and right-hand sums. And left-hand sums are an underestimate if the function is increasing. Like this graph, it's an underestimate because the function is increasing. But they're an overestimate if the function is decreasing. And right-hand sums are the opposite. They overestimate if the function increases, like in this one right here. And they underestimate if the function decreases. So trapezoidal sums, they look like this. So if you have even subintervals, like for example this one, delta x is always 2. It goes from 2 to 4, 4 to 6, 6 to 8. Then you could use this rule. B minus a over 2n times f of, for example this one, f of 2 plus 2 f of 4 plus 2 f of 6 plus f of 8. But if they're not even, you have to use just the area of a trapezoid for each of the intervals. And you do the delta x times the y value of one times the y value of another, divided by 2, and just repeat that. Usually it's like in a table, so you have to like find the delta x and then just use the y values that they give you. Wait, hold on. Let me just use this as an example. For example, this. So for example, if you want to find the trapezoidal rule, if you want to find the trapezoidal sums, delta x it's not always constant. It's 2 here, it's 2 here, it's 3 here, it's 2 here, it's 1 here. So what you have to do is just find the area of each of the individual ones. So it's h, or I don't like h. It's delta x times h1 plus h2 over 2. So for this one, it'd be 2 times 50 plus 70 over 2. For this one, it would be 2 times 70 plus 75 over 2. For this one, it would be 3 times 75 plus 75 divided by 2. 2 times 75 plus 70 divided by 2. And then 1 times 70 plus 50 divided by 2. And then you just do that. Okay, so as you get infinite number of rectangles, then you start approaching the actual area under the curve, like this. You can see that. So, and you can express the limit of infinite rectangles like this. The summation of I equals 1 to n delta x times f of xi. But I think the main takeaway for this is is to just know what to look for whenever you see this notation. So, and you have to know that delta x is equal to b minus a over n and stuff like that. Because this is an example problem. For what value of b does the integral of x squared from 1 to b equal to that? So this just all looks like a ton of stuff, but if you notice that it's written in this form, you can see that 2 over n is the delta x. And so that means 2 is equal to b minus a. So that means b minus a equals 2, so b minus 1 is equal to 2, and b is equal to 3. So that's basically what you should take away from this. Okay, so basically these are some reverse power rule. 1 over x is ln x. And then these, it's basically, if you know your derivative rules, you should be able to know these because it's just like reversing it. And then you have the fundamental theorem of calculus for the definite integrals. And then we do the derivative of an integral in this form. And this is an example of this one. Let g of x equal that. What is the x coordinate of the point of inflection of the graph of g? So, one sec. Okay, so g of x is equal to, hold on, 3x okay, so g prime of x is equal to x squared minus 5x minus 14, and that's just using the fundamental theorem of calculus. And you have to remember that if there's like a function in the top, so say like x squared, you have to use chain rule. So every time you plug in x squared, you have to also multiply by 2x. And then g double prime of x. Oh, wait. Is equal to 2x minus 5. And we want to know the point of inflections. So you set that to 0 and you get x equal to 5 halves. So B would be the answer in this case. U substitution is basically like reversing the chain rule. So you just have to find, the hard part is finding what U is, but then after that, it's pretty smooth. So in this case, you should notice that the derivative of t to the 4th power plus 2t is 4t cubed plus 2. So you do that, and then you can factor out a 2, and you get du equal 2 times 2t cubed plus 1 dt. And then you can do 2t cubed plus 1 dt is equal to 1/2 du. So if you sub that in, you get 1/2 the integral of 1 over u cubed du. And then now you can just do reverse power rule. You do 1/2 times u to the -2 over -2 plus c, and then you sub back in your u expression. Okay. So average value is this, 1 over b minus a of a to b of f of x, of the integral from a to b of f of x. Position, velocity, and acceleration are all related because velocity is the derivative of position and acceleration is the derivative of velocity. If you want to find the area between two curves, you just do from wherever x values they give you, or if they don't give you any x values, it's the points at which they intersect, and then you just do the top function minus the bottom function. Yeah. Or if you don't know which one's the top function and bottom function, you can just choose one, and then if you plug it into your calculator or something and you get a negative value, then just like make it positive. And then if it's in terms of y, it's the same thing, except you kind of just like rotate it, use your y values, and then right minus the left. So volumes with cross sections, semicircles. Okay, so for all of them, it's a to b of like the function squared. For semicircles, it's pi over 8 in the front. For squares, it's just 1. For equilateral triangles, it's square root of 3 over 4. For right triangles, it's 1/2. And for isosceles triangles, or isosceles right triangles, it is, or isosceles right triangles where the function is the hypotenuse, but usually they just say isosceles triangle without like specifying it, so you could just assume that the function is the hypotenuse. It's 1/4. So volumes of revolution, you have disk method and washer method. So for disk method, there's no gap if you want to rotate around the x-axis. So it's just from a to b, and then of the area, which is pi r squared, and r is the function. For washer method, the area is pi of the pi times the outer radius minus the inner radius. So you just integrate that from a to b. Shell method, that's just if you for rectangles. So for rectangles, it all depends on what they ask, because there's a lot of different ways in which they can ask rectangles. For example, they can say like the cross sections with rectangles that are like 3 times the base or something. But yeah, it's kind of I feel like it's not really a good easy way to review rectangles for this one. But if you know these, I think you'll be fine. And also I think it's good to know how to like get these, like just by using like geometry instead of just like memorizing them. So shell method, it can sometimes be easier than washer method. So for example, if you wanted to rotate this area about the y-axis, if you wanted to use washer method, you'd have to do 2 separate integrals, because right here there are places where like the function, like how do I say this? Like you have to do two separate integrals. So one from 0 to a, or f of a, like this value, and then one from a to b. But if you do shell method, you can all just do one integral. And then the area is 2 pi times the radius times the height. So yeah, I think shell methods, you actually don't even need to know it for A, B, but sometimes it's useful, but don't worry about it too much if you don't understand it. Differential equations. So if you're given a differential equation and you want to like solve for like the solution for it, you separate the variables. So 3y squared dy equals 2x dx. You integrate both sides. Y cubed equals x squared plus c, and then just like solve for y. But if you want to have like if they're asking for like a particular solution and they give you like an initial condition, for example, f of 0 equals 5, or they say like f of 2 equals 3, it's good to solve for c right after you integrate. Because when you're like doing all this algebra stuff, like squaring both sides and all that stuff, you could go wrong. But if you just have your c value already, it's easier. Slope fields. So just know how to like, so this is just an example of a slope field question. So what is the differential equation for the slope field? So I see a horizontal line here, so that shows that dy dx is equal to 0 when y is 1. So we can eliminate b and c. And then as you move left and right, you see that the slope isn't always constant. It's like changing. And as you move up and down, it's also changing. So the slope depends on both the x and the y value. So you can eliminate e. And then you could see that for a given y value, so let's just say this y equals 2 right here, there's a negative, the slope is negative when x is negative, and the slope is positive when x is positive. So it can't be d, because x squared means that for a given y value, as x changes, the slope will always be positive. So the answer should be A. Okay, that's it for that. Okay. Okay, let's do some practice problems. Okay, so which of the following definite integrals has the same value as that? So we can do u sub. We can make u equal to x squared. Oh wait. So du equals 2x dx. So x dx equals to du over 2. So we can rewrite this as e to the u du 1/2. Because you take out the x and the dx, and replace them with du over 2. And then the x squared is just replaced with the u. And then we have to change the bounds. So you plug in the original bounds into the u equation. So u is equal to x squared. So the new bounds are 0 and 16. So B should be the answer. Yeah, okay. So for this one, you have to use u sub again. So 2, 4, 1 over 5 minus 3x dx. If you make u equal to 5 minus 3x, du is equal to negative 3 dx. And dx is equal to negative du over 3. So this is equal to, negative 1/3 1 over u du. And then let's just change the bounds. So 5 minus 3 times 2 is negative 1. And 5 minus 3 times 4 is negative 7. Yeah. So this is equal to negative 1/3 times ln of u negative 1 to negative 7. So negative 1/3 ln negative 7 minus ln negative 1. Okay, so on negative 7. One sec. This can be rewritten as ln negative 7 over ln negative 1 negative 1/3. Wait.
Wouldn't you rewrite it as ln negative 7 over negative 1, and then it's just ln 7?
Wait, what?
Wouldn't you just, divide negative 7 by negative 1? So you just get ln 7.
Wait, what do you mean? Sorry.
Wouldn't it just be negative 1/3 times ln 7?
Would it? I mean, it probably is, but like, for some reason, I don't know. I just don't know what.
Isn't that the log rule though? When you subtract, you divide the.
Yeah. Oh yeah. You're right.
Okay.
Okay. Yeah. Okay. No, I know what you mean. So yeah, it's ln negative 7 over negative 1. Yeah. I was like, I knew there was like a log rule, but I kind of forgot what it was. So it's negative 1/3 ln of 7. So it's B. Okay. A particle moves along the x-axis with a velocity given by v of t is equal to 3t squared minus 4. If the particle is at x equals negative 2 at t equals 0, what is the position at t equals 3? So 0 to 3 v of t dt is equal to x of 3 minus x of 0. Squared minus 4 dt is equal to x of 3 plus 2. So this is t cubed minus 4t 0 to 3, which is 27 minus 12, which is 15. So 15 is equal to x of 3 plus 2. So x of 3 is 13. I think it's A. So the graph of a function f is shown above. What is the value of the integral from 0 to 7 of f of x? So it's just finding the area under the curve. And you have to use like geometry, like just area rules. So I'll separate this into a trapezoid. Or if you're not comfortable with trapezoids, you can always like split it up into like triangles too. But I'll just do 2 trapezoids and a triangle. So the area of this first trapezoid is 1 plus 2 times 2 divided by 2. And the area of the second, or which is 3. So this is 3. The area of the second trapezoid is 2 plus 3 times 2 divided by 2, which is 5. And the area of this triangle is 2 times 2 divided by 2, which is 2. So it's 8 minus 2, which is 6. Which of the following is a solution to the differential equation that with the initial condition y of 0 equals negative ln 4? Okay, so we can rewrite this as dy dx equals e to the y times e to the x. So if you separate them, you get e to the x dx equals dy times e to the negative y. So if you integrate both sides, you get negative e to negative y equals e to the x plus c. Right? Yeah, pretty sure. So I'm just gonna solve for c right now. So y of 0 equals negative ln 4. So negative e ln 4 equals e to 0 plus c. This is negative 4 equals 1 plus c. So c equals negative 5. Okay, so negative e to negative y equals ex minus 5. So I think I'm just gonna get rid of this negative because I don't like it. So I'm gonna do 5 minus e to the x. So if you take the natural log of everything, you get negative y is equal to ln 5 minus e to the x. So y is equal to negative ln 5 minus e to the x. C, I think that's the answer. Yeah, I think so. Which of the following is an antiderivative of f of x equals square root of 1 plus x cubed? So it looks like in part A they tried doing reverse power rule, but you can't really do that because it's like a function on the inside. And it looks like on B they kind of misunderstood how to do u sub and how like chain rule works, because that's not the antiderivative of that. Because if you were to take the derivative of this, you'd have to use quotient rule. So it's not A or B. Okay, so C would be 1 plus x cubed and then times 3x squared. So it's not C. D would be 1 plus x cubed times 3x squared. So it's not D. And then E would be square root of 1 plus x cubed. So E is the answer. An object of height h is suspended from a spring is given by h of t equals 16 plus 7 cosine pi t over 4. What is the average height from 0 to 2? So average height is 1 over 2, 0 to 2 of the height.
Wait, why did you just do the 1/2?
Oh, because average is 1 over b minus a.
Oh yeah, which is 2 minus 0. Okay.
Yeah, so it's 2 minus 0. Okay, so this one is 16, or okay, this is annoying. So you have to do u sub for the cosine one. So let's just like separate this into two. Okay, so for this one, it's just 32. 32. But for this one, you have to do u sub. So u is equal to pi over 4 t, du equals to pi over 4 dt. Dt is equal to 4 du over pi. So this is equal to 7/2 times 4 over pi. And I'll sub in 0 and pi over 2. Okay, first of all, I kind of skipped some steps here, but do you get like what that is? I just brought the 7 out, and then made it 7 over 2, and then I brought the 4 over pi out because I subbed it in. I'm subbing it in.
Yeah.
Okay. So cosine u du. So that's 14 over pi. Integral of cosine is sine. Sine u 0 to pi over 2. So that is 14 over pi, and then 1 minus 0. Wait, please tell me. Okay, yeah. So that's 14 over pi. So 32 over 2 is 16. So this is 16 plus 14 over pi. I think it should be d. Yeah. Okay. Let f of g be continuous functions such that the integral from 0 to 10 of f of x dx is equal to 21, and the integral of from 0 to 10 of 1/2 gx dx equals 8, and the integral from 3 to 10 of f of x minus g of x dx equals 2. Was the value of the integral from 0 to 3 of f of x minus g of x dx. Okay. So 0 to 10 f of x dx equals 21. And let's say that from 0 to 10, the integral of g of x dx equals 8 times 2, which is 16. So the integral from 0 to 10 of f of x minus g of x minus the integral from 3 to 10 of f of x minus g of x dx equals the integral from 0 to 3 over f of x minus g of x dx. So if you think about it, like, does that make sense? Like, basically, if you think about it just in terms of like the area under a curve, let's just say this is 3, this is 10. So the area under the curve from 0 to 10 would be this whole thing, and the integral from 3 to 10 would be this thing. So if you subtract the integral from 0 to 10 from the if you subtract the integral from 3 to 10 from the integral of 0 to 10, you'll be left with this, which is the integral from 0 to 3. So the integral from 0 to 10 of f of x minus g of x is just 21 minus 16, which is 5. And then we're given this, which is 2. So 3 is the answer. Okay. Water is flowing into a tank at the rate R of t, where R of t is measured in gallons per minute and t is measured in minutes. The tank contains 15 gallons of water at time t equals 0, and values of R of t are in the table. Use trapezoidal sum with 3 intervals to approximate the number of gallons at t equals 9. Okay, so first of all, from 0 to 9, R of t is equal to, let's just say, I'll just call it f. F of 9 minus f of 0. And we know that f of 0 is equal to 15. We want to know f of 9. And then we're going to approximate this integral using trapezoidal sums. So from 0 to 4, it's 4 times 9 plus 6 divided by 2 plus 3 times 6 plus 4 divided by 2 plus 2 times 4 plus 3 divided by 2. So that is equal to 15 times 2, which is 30, 10 times 3 divided by 2, which is 15, 4 plus 3, which is 7. So 45 plus 7 is 52. So 52 is equal to f of 9 minus 15. So f of 9 is equal to 52 plus 15, which is 67. Okay. How many more do we have? 3 more, okay. So the base of a solid is the region bounded by the x-axis in the graph y equals square root of 1 minus x squared. And each cross section is a square. Okay, so the integral from a to b of f of x squared dx, that's all we're looking for. Now what's a to b? Well, first of all, I noticed that this is the area of a semicircle with the radius of 1, so I know that it's from -1 to 1. So -1 to 1. And then square the square root, you just get 1 minus x squared dx. So that's 1 minus x cubed over 3. -1 to 1. So that's 1 minus 1/3 minus -1 plus 1/3. So that's 1 plus 1 minus 2/3, which is 2 minus 2/3, which is 1 and 1/3, which is 4/3. B. What is the solution to the differential equation that with the initial condition y of 0 equals 3? So you separate the variables. So 1 over 5y squared dy equals dx. So you have to use reverse power rule. So you can rewrite that as 1/5 y negative 2. So you add 1, so -1, and then divide by -1 equals x plus c. So that's -1 over 5y equals x plus c. So I'm going to solve for the initial condition right now. plug in 3 for y and 0 for x. So c is equal to negative 1/15. So negative 1 over 5y equals x minus 1/15. So I'm just gonna make like a common denominator. Or well, okay, so I'm gonna do this. Negative 1 over 5y equals 15x minus 1 over 15. So what do I do? Okay, I'm gonna multiply 5y. And then I'm gonna divide by 15x minus 1. And then I'm gonna make this y over 3. So this is negative 3 over 15x minus 1 equals y. Okay, so there's no answer choices that are in this form, but we can factor out a negative 1 out of 3. So negative 3 over negative 15x minus 1 equals y. So that's 3 over 1 minus 15x equals y. D. Okay. So this is the last problem. So let R be the region bounded by those two equations. For each solid, there's a cross-section perpendicular to the x-axis with an isosceles right triangle. Okay. So each cross-section is this. And then if you like make it a isosceles right triangle, you see that this is this is f of x, and then there's going to be another leg that's also f of x, and then 3, so it's f of x like that. So the area of each isosceles right triangle is f of x squared divided by 2. So you're going to integrate that from 0 to 2. 1/2 f of x squared dx. So what is f of x? So f of x is the top function minus the bottom function. It doesn't really matter, like if you know what, like you can just guess. So I'm just going to guess that this is the top function. So 4 cosine pi x over 4 minus x minus 2 squared dx, 0 to 2, 1/2. So you plug that into your calculator. 4 cosine you get 1.775, right? Okay. So that's all I have today. Is there any like things that anyone wants to go over again?
Could you go over cross sections again?
Yeah. Okay, 1 sec. Okay, so basically, when they ask you to make volumes with cross sections, you're doing this. So let's say this is your function, the red line. You're making like cross sections like this. So for example, if they ask for semicircles, you're doing that. So how to do it is you integrate from A to B, and then of the area of each, you integrate the area of each cross section. So what's the area of each of these cross sections? Say, for example, the semicircles. The area is pi times f of x squared divided by 8. And I got that doing this. So the volume that's formed from these cross sections are pi over 8 from 8 times the integral from a to b of f of x squared. And then for squares, it's just the area is different. So instead of pi over 8 f of x squared, it's just f of x squared. So, and it's the same thing. So like what part are you like confused on?
Well, how'd you get from pi over 2 to pi over 8 for the semicircle?
Okay, so for each semicircle, the base of the semicircle is the function, right? So the area is pi r squared divided by 2. And so the radius is f of x divided by 2. So it becomes f of x squared divided by 4. Right?
Yeah.
Yeah, and then the 4 is then in the denominator, so it becomes pi over 8.
Okay. Wait, but why? I don't get the f of x over 2 squared.
Well, the area of a semicircle is pi r squared divided by 2, where r is the radius of the semicircle, right?
Mm-hmm.
And the diameter of the semicircle is just the function, right?
Yeah.
So the radius is f of x divided by 2.
Oh, okay.
All right. All right. See you guys. Okay. So what else are you like confused on? Sorry. Like besides. I'm sorry. I don't
know. Like I get the general premise. How do you differentiate between each triangle?
Okay, well, so for equilateral triangles, it's just like an equilateral triangle. But I mean, so for these ones, I've never actually seen them use isosceles triangles, but isosceles triangles are where like the function is the hypotenuse. So it's like this. And then right triangles are when the function is just a leg of the right triangle, and it's like an isosceles right triangle. So it's like that.
Mm-hmm.
And then equilateral triangles, the function's the base, but all the sides are the same.
Mm-hmm.
Does that answer your question?
Yeah.
I mean, are you sure?
Can you walk me through how you got that, like those equations?
Okay, so for equilateral triangle, let's say f of x is the base. So you can split it into two triangles where the base is f of x over 2, the hypotenuse is f of x, and we want to solve for h.
So you're just turning into like a right triangle?
Yeah.
Okay.
So h is equal to square root of 3 f of x divided by 2. And you could do that using like Pythagorean theorem, or if you know your 30, 60, 90 triangles, you can know that. So then the area of the whole entire triangle is 1/2 base times height, where the base is f of x, and we know the height is square root of 3 f of x over 2. Right?
Mm-hmm.
So if you do that, you get square root of 3 over 4 times f of x squared. So that's how you get that.
Okay.
Yeah.
So what? How would?
Sorry.
Wait, how would you know when to use like an equilateral or right? or
They'll tell you. They'll tell you.
Okay, good. Okay, good. Okay,
Wait, wait, did you think we had to like just guess? All right. Okay, so for right triangles, it's just like this: 1/2 base times height. So it's 1/2 f of x times f of x. And for isosceles triangle, for like 45 triangles, the hypotenuse is the base times square root of 2. So f of x equals b square root of 2, so b equals f of x over square root of 2. And since the area is 1/2 b squared, you can just plug in this for b, and then that's how you get that.
Okay, that makes sense.
Any other questions?
Can you share all this stuff with us?
Yeah.
Like the questions and the slideshow?
Yeah.
Okay, thanks.
Or well, the questions, they're like on the Discord, but I'll share the slideshow.
Okay.
Any other like concepts or anything that anyone wants to review again?
Wait, what are the questions?
They're like, I made like a whole separate like thing for them. It's like here, hold on.
It's in the reviews, like the review section. So there's like limits, derivatives, and integrals. So it's
Okay,
like under all the text channels.
Okay, I see them now.
Okay. Any other questions? No questions.
No?
Okay.
Wait, how many questions do you think, like generally, would you need for like a 5?
Okay, so I think you can. Let me just look it up real quick.
I'm feeling like a mid-60s curve. That's not
Okay,
feeling.
wait, hold on.
Yeah, I feel like the curve might be different because this year is very different.
Okay,
No.
so
Yeah, well, doesn't it also have to do with how well you do on the free response questions?
It's each 50-50.
okay, so if you get 50% on like everything, you'll get a 3. So let's say you get 50% on the FRQs. So what score are you looking for? Like a 4 or 5 or what?
Well, hopefully a 5.
Okay, well, in order to get a 5, if you get 50% on all the integrals, you'll need to miss like, you can miss like 10.
Okay.
Depending
That's just
on
the
the curve.
projected, though.
Yeah, this is just
Yeah,
like,
this is just projected though. I already
could be lower, could be higher. Most likely going to be lower though.
I feel like lower because more people, since it's online, more people are likely to do worse.
Yeah.
Let's say you just did really good. You got 40. Then you can you could get like less than 50. You could get like less than 50.
You could bomb that FRQs.
Yeah.
Or like you could do like really good on like a couple FRQs, then just completely bomb the others.
Yeah. And let's say,
Like you got like a 7 out of 9.
yeah, okay, yeah. Let's say
Uh,
you did really good on one FRQ. If you do really good on one FRQ, you can like bomb another FRQ. Basically, let's say
you completely bombed.
let's say you did really bad. You got a 20.
Oh.
Uh,
Oh.
okay. To be honest, if you can't do good on the MCQs, I don't think you'll be able to do good on the FRQs. But let's just put that aside. You'll need to do pretty good, I think.
You'll need a.
Yeah, you'll need to like basically ace every FRQ. But I don't know. Who knows? Maybe like your calculator shut down or something during MCQs. You can make it up.
The MCQ should be easy though.
Yeah, but to be honest, yeah, if you get a 20 out of 45, I don't know if you'll be able to get like an 8 out of 9 on all the FRQs.
I mean, when I was doing practices, my highest MC, multiple choice, like 37 or something.
That's
Mhm.
good.
But I didn't score my FRQ. I was too scared to look at them. So.
Oh. Okay. Well, any other questions?
No.
I guess just general suggestion would be like maybe tonight, like just read over some of College Board's like FRQs from past years, so you could get like used to the wording, because I know their wording's kind of weird.
I have an off-topic question.
Yeah. What?
Have any of you guys been able to sign up for an SAT?
I
If you guys are signing up,
I don't take the SAT.
you just don't.
No, I don't like the SAT.
So you're not planning on it then?
No, I don't plan on. I already took the ACT.
Oh, okay. Well, like anyone else, because all the test centers are still closed in California.
I'm probably planning on ACT as well.
Yeah, same. I don't know. I just feel like SAT doesn't work it. I might just take ACT.
No, I just hate College Board.
Yeah.
You think? Do you think like AP scores are weighted that much in admissions?
I think it depends on the college.
Okay. Because I've seen like, and I've heard various things. It's just, and I've heard various things. Okay, that's it.